All right, so today we're going to look at vertical line tests, horizontal line tests, and inverse functions. And we're going to start off with vertical line test. And I'm not quite sure if this was in the previous math class, Math 102. But a vertical line test, it tests for functions. Okay, so if you're given a graph, you can tell if the graph is a function by performing a vertical line test. If you're given a function itself, like f of x is equal to, let's say, x squared plus 3 or something to that effect, based upon what we know about algebra's common graphs, and we can determine if the function is an actual function, okay, just by the nature of the way the graph looks and by performing this vertical line test. So the vertical line test states that a vertical line drawn intersects the graph in no more than one point. The graph is a function. Okay. So if we take any graph and if we draw a vertical line, okay, a line that runs from north to south, if there is no more than one point of intersection, then the graph is a function. Okay, so here are some examples. Okay, so the directions read function or not. All right, so on the first one, we're going to take the parabola, right? Y is equal to x squared. Right, so I'm given a graph, right, a U-shaped parabola graph, and I know this should be some type of quadratic equation, right? So sometimes you may be given a graph, sometimes you may be given a function. Okay. So if you're given a function, we can actually make a rough sketch of a graph, which would be the U-shaped graph. If I were to apply a vertical line, right, notice that the vertical line intersects the graph at no more than one point, so this graph is a function. If we look at another example, all right, and this is a C-shaped graph, and we don't really deal with these graphs too much in this class, but this graph does have a basic form, and it would be x is equal to y squared. Right, so notice in the first one, the x variable was squared, and in the second one, the y variable is squared. So here again, I'm going to perform a vertical line test. Right, so if I draw a vertical line, notice that we have more than one point of intersection. So this graph is not a function. All right, so if you draw a vertical line, if there's no more than one point of intersection, we have a function. If there is more than one point of intersection, then the graph is not a function. Next, we're going to talk about a horizontal line test. And a horizontal line test, it tests for inverses. Now, inverse and this term 1 to 1 are the same. Right? So you would use a horizontal line test to see if an inverse exists for a function. So once we determine if an inverse exists for a function, then we'll be able to actually find the inverse. And the definition is much the same as a vertical line test, but instead of drawing a vertical line, we will draw a horizontal line. So the definition says that if a horizontal line is drawn, and there is no more than one point of intersection, all right, so for a horizontal line test, the definition states that if a horizontal line is drawn and there is no more than one point of intersection, then the graph is 1 to 1. And 1 to 1 means that that graph has an inverse. So let's take a look at some examples. All right, so if we take a look at this V-shaped graph, all right, and from the algebra of common graphs, the general form for that would be y is equal to the absolute value of x. Notice that this is a function, right? If I were to perform a vertical line test, it is a function. Okay, but is it 1 to 1? In order to determine if it's 1 to 1, I will draw a horizontal line. Right, notice that I have 2 points of intersection, which is more than 1. So it's a function, but it's not 1 to 1. Right, so that means that this function does not have an inverse. Okay, and we will take a look at this. Right, so this is in the form y is equal to the square root of x. Right, so if I were to draw a vertical line, right, it is a function because it passes a vertical line test. It would also be, well, if I were to draw a horizontal line, right, it would also pass a horizontal line test, right, because there is no more than one point of intersection. So this is a function and it's one-to-one. So now the way the book is set up, it asks you if it's a function and if it's one-to-one. All right, so you have to perform both a vertical and horizontal line test. Now let's just say you're given functions. All right, so the directions are the same function or not. So we're given y is equal to 9x plus 7. Right, so I'm not given a graph, I'm just given a function, and I'm asked to determine if it's a function and one-to-one. So I'm going to add that to the directions. So now, just based on the equation itself, y is equal to 9x plus 7. Right, I'm going to just go over here to the side and algebra's common graphs. So if you have y is equal to x, so really what I'm concentrating on is the variable x and the power that it has. So in your equation, if you have an x raised to the first power, the graph should look something like this, right? A straight line. If you have y is equal to x squared, right? Remember that's a parabola. Y is equal to x cubed. Right, if the cube is the highest power, keep in mind that that is an S-shaped graph. If you have y is equal to the absolute value of x, right, that is a V-shaped graph. Y is equal to the square root of x. There's no special name for this graph, but it would take on this form. And then I believe we looked at the rational function, y equal to 1 over x. I believe the graph looks something like that. Okay. Now, as we go further along in the course, we'll be adding to this. We'll be talking about exponential e, and we'll also be talking about logarithms. All right, so just based on algebra's common graph, y is equal to 9x plus 7. It's going to be a straight line, a slanted line, right? So if you were to draw a vertical line test, right, it would be a function, right? If I were to draw a vertical line test, it would be a function. And if I were to perform the horizontal line test, it would also be one-to-one. And we'll take a look at another example. Y is equal to negative 4 minus 4x squared. All right, and we're asked to determine if this is a function and if it's one-to-one. So keep in mind that the largest power for our variable is a square, right? So if we were to graph, we would have a parabola. Since the coefficient of x squared is negative, that would actually give us an upside down U shape. If we were to perform a vertical line test, it would pass, right? Because there's only one point of intersection, so this is a function. However, if we perform the horizontal line test, it would fail, right? Because it has more than one point of intersection. So this is a function, but it's not one-to-one. Okay. Now we're going to look at relations. And a relation is a set of ordered pairs. All right. So we want to identify a function and one-to-one. So we have 1, 6, 3, 2, 1, and 5. We have 1, I'm going to use some different numbers, 2, 4, 8, 4, 3, and 2. And then we have a third, 0, 2, 1, 5, and 3 and 4. And we're asked to identify a function, and the function is one-to-one. Now, if we're looking at ordered pairs, this is what we want to keep in mind. A function has no repeating x values. For a one-to-one, there are no repeating y values. Okay. So we want to choose the one that's a function and is one-to-one. So in a nutshell, I want to pick the relation that has no repeating x values and no repeating y values. Okay, so that's the main thing to look for here. So if we look at, let me just give you some answer choices. If we look at answer choice A, notice we have 2 repeating x values. All right, so that's not a function. If we look at answer choice B, Notice that all of the x values are the same, but we have repeating y values. So if you kind of think about a horizontal line test, that horizontal line test, if it fails, you would have two ordered pairs with the same y value. So for answer choice B, that is not 1-to-1. Okay, if we look at answer choice C, notice that there are no repeating x values or y values, so the correct answer choice should be C. All right, so we are looking for the relation that has no repeating x values and no repeating y values. All right, so now that we talked about how to identify a function and how to identify if a function is 1-to-1, now we're going to write out the steps to find the inverse. Okay. Now a function has an inverse if and only if it's 1-to-1. All right, so find the inverse. So we have f of x is equal to x plus 10, and I'm asked to find the inverse. Okay, now for the problems that we're given, we're asked to find the inverse, so that's automatically assume that it's 1-to-1. So we don't have to check for 1-to-1, we just simply have to find the inverse. Here are the steps to find the inverse. Okay, and there's only 3 steps. The first thing we do is interchange x and y. Right, so what does that mean? That means wherever I see an x, I'll replace it with a y, and wherever I see a y, I'll replace it with an x. Okay. So as I actually write the steps out, we'll perform the steps. So remember that in function notation, we let y equal to f of x. So the first thing I'm going to do here is I'm just going to clearly state out all x's and all y's. So I'm going to rewrite f of x is equal to x plus 10 as y is equal to x plus 10. Now I'm going to interchange x and y. So I have y is equal to x plus 10. So I'm going to write this out as x is equal to y plus 10. All right, so I just flip-flop the x's and the y's. Once you have interchanged x and y, the next step is to solve for y. Right, so in order to solve this for y, I'm simply going to subtract 10 from both sides. So I have y is equal to x. Well, let me just write this out. The third step is to solve for y. So we have y is equal to x minus 10. Right, so I subtracted 10 from both sides and I kind of flipped it around just so that y is on the left-hand side. And here is the third step. We simply replace y with the inverse symbol. Now, even though that is is looked at as f to the negative first power x. That's read as f inverse of x. So you don't actually read that negative first power. That's actually read as f inverse of x. So that negative 1 power, if you want to look at it that way, it alludes to the inverse. All right, so the fourth step is to replace y with f inverse x. Okay, because y is not actually a y, that's an x in disguise because we flip-flopped them. So our final answer would be f inverse of x is equal to x minus 10. All right, and we will look at another example. So here again, we're asked to find the inverse. So we have f of x is equal to x divided by x plus 1. Right, and we're asked to find the inverse. So the first thing I'm going to do is I'm going to let y equal to f of x. So if you're not actually given y is equal to, the first thing you should do is rewrite f of x as y. So I'm going to write this out as y is equal to x over x plus 1. The second thing I'm going to do is interchange x and y. So I'm going to write this out as x is equal to y divided by y plus 1. And now we will solve for y. So here's the thing to do. First thing I want to do is I want to get all my y's on one side of the equation. And as I look, I already have the y's on one side of the equation. But I'm dealing with a fraction on the right-hand side. So in order to solve for y, the first thing I want to do is clear the equation of fractions. So in order to solve for y, the first thing I'm going to do is multiply both sides by the least common denominator. And the least common denominator here would be y plus 1. All right, so I'm going to multiply the left-hand side by y plus 1. I'm also going to multiply the left-hand side by y plus 1. So we're going to remove the fraction by multiplying both sides by the least common denominator, which is y plus 1. So when I multiply the right-hand side by y plus 1, right, x times y is xy. X times 1 is x. And on the left-hand side, the y plus 1's cancel, so I am left with y. So from this point, I want to get both terms that contain y on one side of the equation, and I want to put the terms that don't contain y on the other side of the equation. right? So here's what I'm going to do. I'm going to take y, and I'm going to transpose it, and I'm going to move it to the left-hand side. So I'm going to subtract y from both sides. And then I'm going to take x, and I'm going to move it or transpose it to the right-hand side. So I'm going to subtract x from both sides. So my equation should look something like this. xy minus y is equal to negative x. Right, so I move y to the left-hand side, so I subtracted y from both sides. I moved x to the right-hand side, so I subtracted x from both sides. Now we have the terms containing y on the same side of the equation. We don't have any fractions. So now on the left-hand side, I'm going to factor out y. Right? So if I factor out y, I'm left with x minus 1. Right? Because if I go back and distribute, y times x is xy, and y times negative 1 is negative y. Now, in order to solve for y, we're going to divide both sides by x minus 1. So we have y is equal to negative x over x minus 1. So we have solved for y. And the last thing to do is replace y with f inverse of x. So our final solution is f inverse of x is equal to negative x over x minus 1. So that's how you find the inverse if you're given a function. Just those 3 steps. Interchange x and y, solve for y, and then replace y with the inverse symbol. But what if you're given an ordered pair? All right, so here again, the directions are to find the inverse. All right, so we're given this relation 2, 1, 5, 6, and 7, 9. All right, so if I'm given a relation, which is just a set of ordered pairs, how do I find the inverse? All right. So we're going to pretty much do the same thing we did when we found the inverse of a function. The first step was to interchange x and y. So that's what I'm going to do, is just interchange x and y. So here's what the inverse should look like. So I'm going to have 1 and 2. So I'm basically just flip-flopping x and y. 6 and 5, 9 and 7. And this would be our inverse. All right, so we flip-flop x and y. So we have 1 comma 2, 6 comma 5, and 9 comma 7 as the inverse. All right.